This is number 2 on the blue worksheet. So we have a stone that is thrown vertically upward with a speed of 18 meters per second. So the fact that it's thrown vertically upward changes this projectile to actually not really a projectile. So it doesn't have any lateral distance, it only goes up and down. So we don't need to do an XY table, we are just working with one direction. So we're trying to figure out how fast it was moving when it was 16 meters above the release point, and at what times potentially was it at this height. So using the fact that we know gravity, we know an initial, trying to find a final, and we're given a distance, it's most important to do v final squared is equal to v initial squared plus 2 gravity delta y. Plugging in what we have, we're trying to find the velocity at 16, which is why I have it written as v16. That's equal to the square root of 18 squared plus 2 times the gravity times the distance of 16. So moving that around, doing the solving, we end up getting a velocity at that position of a value that could be positive or negative, because when you take that square root, that means that you get one or the other. Calculator is only going to give you the positive, and I'm only going to write the positive right now. So that's going to be 3.22 meters per second. Right now, as far as problem solving goes, that makes sense because when you throw something up in the air, it is consistently getting slower. So it starts with a value of 18 meters per second, and as it moves further up in the air, it slows down until ultimately it reaches 0. Now, the other thing that happens is that on the way back down, because gravity causes things to fall, it's going to speed up from 0. So this 3.22 meters per second is going to happen at 2 different spots. So that's why we have to pay attention when we're trying to figure out our time. So knowing what we know about the values, we've got v final y, which is equal to v initial y, plus gravity times time. V final that we're talking about is 3.22. V initial was 18, and then gravity negative 9.81 times t. So our t value is going to be what we get when we solve. So we do 3.22 minus 18 divided by 9.81. We get 1.5 seconds. Now that's the time it took going up. So from release, we went 1.5 seconds upward and reached that point. Now what we end up doing is trying to figure out the down. So when we look on the way down, we had the projectile that goes up and then down. So even though I said it wasn't a projectile, it's still technically a projectile. So it's going to reach that speed and be at 16 meters in 2 different locations. So we need to figure out the best option to go to find the time. So we have some options. The best thing I think is to use the peak, but you also have options where you use the release and the symmetry, so a couple of different choices. But I think that it's best to use this option. So I'm going to find the time to the peak, and that's going to be v final y minus v initial y divided by gravity. V final is 0, v initial was 18, so I'm going to do negative 18 divided by negative 9.81. That's going to give us our value for the time it took to reach that point. So it took 1.83 seconds to reach that peak. And even though it took 1.83 seconds to reach the peak, we need to figure out then what's happening at that point. So the change in height up to the peak, 1/2 gravity times squared. I'm going to go from the way down instead of on the way up. That's 1/2. 9.81, 1.83 squared. And then from there, we're going to use the calculation to get how high above the starting point the peak actually is. And when we do all the work, we end up getting 16.42. So that means our projectile is going to have to fall from 16.426 down to 16. So it's going to have to experience a delta y of 0.426 meters. So we are going to use that 0.426 meters to calculate the time it took past the peak to fall back down. So our delta y here is going to be 1/2 gt squared. Again, using the peak. So negative 0.426 is 1/2 gravity, and then we're solving for time. And when we do that, we'll ultimately get our time value of 0.295 seconds. So that 0.295 seconds is after the peak. So to figure out the total time from release to hit that 16, we would need to add the peak time, which was the 1.83, to the time it took to fall, which is the 0.295. So ultimately what happens is after release, we are hitting that 16 at 2.12 seconds. So at both spots, we are hitting the 16 meters. So on the way up, after 1.5 seconds, and then on the way down at 2.125.